So now let's look at one example for the inverse Laplace transform, which involve the unit step functions. So inverse Laplace transforms involving unit step functions with unit step function. Okay, so if it is for example f of s is e power minus s over s square plus pi square plus e power minus 2s over s square plus pi square plus e power minus 3s over s plus 2 square. So if this is the Laplace transform given, so if we want to convert it back to its original function, then how we can do that? So we have to look at these term by term. So the first term indicates that it is something like which is related with the sine function, and similarly for the second term. The third term is indicates that it is something related with the t. Okay, so for example, we know that the Laplace transform of sine of omega t is equal to omega over s square plus omega square, and then Laplace transform of t is equal to 1 over s square. Okay, so since it is this is s plus 2, so this will be this can be also represented like this: e power at times t. It will be by the first s shifting theorem, it will be s minus a square. So this will be the last term will be of this form. Anyway, so we can rewrite these terms as like this. So I can put pi over here, and then pi e power minus s over s square plus pi square. I can write like this because for sine it was omega was here. So if pi is omega, then that omega should be here, and then we have to divide it by pi over here as well. So similarly for the second term, I can put pi, and then it will be e power minus 2s over s square plus pi square. And for this, okay, let's write it just like this as of now. So now I will start to convert them into their Laplace transforms, into their functions. These are the Laplace transforms, that's what the functions. So what will be the function? So function, now I can write. So y1 over pi as it is. So this will be sine of t. Okay, this will be sine of not t, it will be pi t, sine of pi t. Okay, and since now it is being multiplied by e power minus s, so this means that we have to use the unit step function. Okay, because we know that from the t shifting theorem, the Laplace transform of f of t minus a into u into t minus a is equal to e power minus s into f of s. So if this is f of s, and then that it is going to be multiplied by e minus s, so these t terms should be in this manner. So therefore it should be minus a over here. So it should be pi, and then t should be in terms of t minus a. And what is a? Is 1. A is 1. Okay, and then it should be a unit step function over here, u into t minus 1. and the next term is 1 over pi. So this will be again sine pi of t minus 1. Okay, because this pi comes from here, omega. Okay, so it should be pi omega, sorry, pi omega t. So but t is replaced by t minus 1, and then multiplied by u into t minus 2. So here it should be t minus 2. Yeah, not t minus 1, because it was minus 2s. And then for this term, okay, so this term, it's already now multiplied by the s shifting term, so it will be well, it will be t, but it should be t multiplied by a. So t multiplied by e power minus 2t. Okay, t multiplied by e power 2 minus 2t into u into u of t minus 3. Okay, u of t minus 3. Okay, so this is the f of t, but let's just simplify it a little bit. So for the simplification, we know that this term is sine pi t minus pi. So what is sine pi t minus pi? Sine pi t minus pi. So from the sine alpha minus beta, we can expand it like this: sine pi t and cosine pi minus cosine pi t sine pi. So sine pi, we know that it is 0, so this term is 0, and cosine pi is minus 1, so it will be minus sine pi t. So this term will be minus sine pi t. And how about here? So it is sine pi t minus 2 pi. So sine pi t minus 2 pi. So similar manner, sine pi t cosine 2 pi minus cosine pi t sine 2 pi. Here we know that the cosine 2 pi is 1, not minus 1. So and this term is 0. So it is equal to sine pi t. Okay. So f of t will be then minus sine pi t over pi u t minus 1, and then it will be plus sine pi t over pi u t minus 2, and then plus t into e power minus 2t. And yes, here I think I should have put t minus 3, because every term for this pi should be in terms of t minus 3, so it should be t minus 3. Yeah, I made a mistake here. It should be t minus 3 into unit step function of t minus 3. Okay, so therefore now how we can represent this function in the normal format. So for example, the normal format will be like, we need to give the options of these functions. So for any value of t less than 1, so from 0 to e to 1, so this term will be 0, and every term will be 0. So this function is 0 from 0 to 1. Okay. For values of t between 1 to 2, so 1 to 2, so what will be this value? So this will be 1, this value is 1, and then this will be minus sine pi t over pi, and this will be 0, this will be 0, so this will be minus sine pi t over pi. And for values of t between 2 to 3, 2 to 3. So this is 1, so minus sine pi t over pi, and this will be 1, so it will be plus sine pi t over pi. So minus sine pi t over pi or plus sine pi t over pi will cancel out, so it will be 0. And for value of t greater than 3, minus sine pi t over pi plus sine pi t over pi, they will cancel, okay, because these two will be 1, these unit steps will be 1, and this will be 1, so only thing remaining will be t minus 3. It will be, yeah, here it should be also t minus 3, not t. Yeah, I think I should have represented it better. So t should be represented by t minus 3. T minus 3. Okay. And here also t minus 3. Anyway, so it is t minus 3 e power minus 2 into t minus 3. Okay. So in this way we will represent this function whose Laplace transform was initially given, and then we did the inverse Laplace transform and then find the function. So it is the step function we have converted.